Now we're going to look at types of functions. This first bit of information should be familiar. Your slope formula. M is the symbol we use for slope. Difference of y's over difference of x's. Whatever y you use here, its x value must be right below it. And normally that's how I do my slope. I'll look at one point, put the information, do my subtraction, and then go to the other point instead of going back and forth between the points, which is sort of time consuming. Another formula that you need to know, slope-intercept form of a linear equation. You have y equals mx plus b, where m, again, is your slope, and b is your y-intercept. If x were 0, I would have the coordinate point 0, comma b, which is, by definition, what a y-intercept is. So, first bit of homework, find the slope of the line passing through each pair of points if possible. So I need you to pause me and do this because you should already know how to do these. So do all three of them and then unpause me and we'll see if you agree with what I've got. I'm going on though, so pause. So I'm going to go and get one of my coordinate points. I chose to use the first one. A lot of people will go for the second one because they have been told in their past that the sub 2 means the second point, which is all right. Technically that's not right. Whoever told you that, if you were told, we're just trying to keep you to keep the formula consistent. But we'll see if we end up with the same thing. So I put my y value over my x value, my subtraction, and the other points, y value and x value. I have for a long time always used parentheses, and I clean it up. Some of you I know will put a plus plus. That's up to you. But I will take an extra step, clean it up. So my numerator is 12, my denominator is a -5, and usually if there's a single negative, float it to the numerator. So if you had used this second point first, you would have ended up with this. So we got the same thing. In this one, put my y over x, my other y and my x, cleaned it up. Notice I have got division by 0. Now, if you plotted these points, this point I'd go to my right 8, down 5, again, right 8, up 2. If I connected, I would have a vertical line. Anytime I have a vertical line, I'm going to always have 0 in the denominator. Do not call this no slope. This slope is undefined. Okay, slope is undefined. In this one, if you find your slope, you'd end up with 0 over 2. And anytime you have 0 over a non-zero number, that equals 0. Okay, so the slope here is 0. Now, if you plotted these points, this would be right 17 up 7, right 19 up 7. And if you connected those, you would end up with a horizontal. Now, one way to remember that a horizontal line has slope of 0, well, there's not many words that you use that have a Z. So 0 is Z-E-R-O, horizontal, H-O-R-I-Z. So both of them have a Z. So a horizontal line has slope that's 0. Okay? Interpreting slope in applications, that means word problems, and you're going to have them. Involving linear functions, the slope is interpreted as a constant rate of change. Now, the units for this rate of change can be found from a graph by placing the units from the vertical axis, the y-axis, over the units from the horizontal axis, because that's your slope formula, y's over x's. And I actually mean word problems, okay? And if you've got words and you're asked to interpret, then go and see what is the y-axis and what's the x, or what is y representing and what's x representing. So I've got an example. The median age of the U.S. population for each year T between 1970 and 2010 can be found approximated by this formula. So A of T, okay, age, and T is time, your year, is given by, and this is linear. Here's my slope, and here's my y-intercept. Now it says compute the median ages in 1980 and 2000. Well, my T here is time, and that's my years. So they're wanting me to put 1980 into my function. So let me get my calculator. I'm going to put 1980. I'm going to store it in. Let me type in my problem. So 0.243. Now if you notice, I put it in for x because if they have a t here, I could interchange that with another variable. So since x is so convenient, I like to use it. Minus 450.8. So it looks like the median age for 1980 was about 30.34 years. So let's see what I've got. For 1980, we find A of 1980, 30.34. So the median age in 1980 was about 30. Well, let's do the same thing for 2000. So let me store 2000. And for my x, do you remember how I recall? Second enter, 35.2. So in 2000, the median age has gone up. So let me see how I phrase this. For 2000, we find A of 2000, which is 35.2. So the median age in 2000 was about 35. Okay, there's a B part here. What is the slope of the graph of A, and interpret that slope? Okay, here's when you see the word interpret, this is when they want you to get those units. Now remember, my y value here is referring to median age. Remember, A of t is my y. So that's median age, and t, notice where the x is, or you know, is supposed to be found, and that is time or year. Now my slope here is 0.243. So I could say that the median age is increasing, since my slope is positive, by 0.243 per year. So the slope is 0.243. Median age of the U.S. population is increasing by 0.243 each year. Remember that the y value in this problem is median age and x value is year. So if you use your formula of y's over x's, you will have, and I call this a word fraction, but it helps me for the interpretation because I can say median age per year. And again, I say the slope is positive, which indicates that the median age will continue to increase each year. And we saw that true here when we looked at 1980. The median age was about 30, and in 2000 it's about 35. So it is going to continue to increase. Okay. So think about a word fraction when you see the word interpret the slope. You will have to do that. Okay, now in this section it was types of functions. So now we're going to go recognize nonlinear functions. If you know y equals mx plus b, then you'll be able to find which ones are your linear functions here and which ones aren't. But we can still graph them. Let's see, if a function's not linear, then it's called a nonlinear function. That's sort of like a dictionary definition, but that's okay. The graph of a nonlinear function is not a straight line. So we're going to graph the following functions on your calculator to determine if they're linear or nonlinear. And if f is linear, we're going to determine if it is a constant function. So let me clear all that off. Let me go to y equals. Now remember, f of x and y are the same, so I've got y equals 2x minus 3. So this should be linear, because my x value, if it's raised to the first power. Let's graph it. Slope is positive, which means it's increasing, so if you'll notice, it is straight. So this one's linear. Number 2, to indicate a lead-off negative, you have to hit the negative in parentheses. Now before I ask it to graph, I want you to think about this. The only way that x would not be here is if it had a coefficient of 0. Let me ask this to graph. If you'll notice, it is a linear function. It's a straight line. If you'll also notice, it's horizontal. Slope is 0. Another way I could write this would be y equals 0x minus 3. Now when it says determine if it's a constant, What that means is regardless of what x I put in, it's always going to be negative 3. F of 0 is going to be negative 3. F of 5 is going to be negative 3. So it's constant. It does not change. So if I have a slope of 0, or I have a horizontal line, it is a constant function. See, number 3. You should remember number 3 in the absolute value, but do you remember where we can locate that at? It's under math. Go over to number, and then hit enter. Type in 4x minus 2 parentheses. Do you remember that the abs is a V formation? Now you can't look just at half of this. Half of it is straight, but you look at the whole thing. This is not a straight line. A straight line, you can use a straight edge and go from one end to the other. This is not linear. So this one, go back to y equals. I can put in 1/2 or 0.5. You can do that if you want. X raised to the third plus 1. Exponent's 3. Let's see what we get. This is called a cubic. This is not a straight line. Looks like it sort of started out like that, but somebody sort of turned it a little bit or dented it. But it's not a straight line. Let's see, one more. I believe, yep, number 5. Square root x plus 4. There's a curvature to it. It is not a straight line. So the only two linear functions that we have are number 1 and number 2. So again, let me move back up here. This is slope-intercept form. You've got slope, x is raised to the first plus a constant. And the only two that take on that form are number 1 and number 2. Absolute value? Nope. Power other than 1? Nope. A radical? No. Okay? Thank you.